Okay guys, this is class 9 and we are continuing the MATLAB for the summer 2020. And so as you know, I moved the midterm to the June 16th to make sure that I cover all the topics needed for the midterm. Okay, so now let's continue our MATLAB. So I'm gonna upload the note part 2 to make sure that you have the all notes by Blackboard before midterm. So we covered only this point. Okay, so now solving nonlinear equations using fsolve. So in the previous class we used solve command, as you can see here. The solve command like this. That's right. So but it in some cases it automatically shifts to VPA solve after command of Matlab to solve, and we saw that by using we can solve the equations symbolically, as you can see here. We did it. So for dealing with the robotic problems, we typically need to solve coupled nonlinear equations, namely inverse kinematic problems. Okay, so when you become a robotist, so you're going to pass a robotic course, you have to sometimes solve for the inverse kinematic of the robots, or for finding the equilibrium points of the nonlinear systems in the control classes. So you have to solve for the nonlinear equations. So therefore, we need a powerful tool to solve coupled nonlinear equations. Even in ME 513, that is the undergraduate control, and ME 696 is linear system theory that I'm teaching, we have to calculate the so-called equilibrium point through solving coupled nonlinear equations. For example, suppose we want to solve for x1 and x2 of the following nonlinear equations. You see that? These are the equations, guys. So the funny point is, these are the equations. See, x1 and x2. Are you looking for the analytical solution? Really? Okay, seriously? Good luck, because except some very few numerical methods, you cannot solve this analytically. So we can solve the complex coordinate equations through MATLAB code. Okay. Now how are we gonna do that? First of all, you have to open. Now we're starting to coding in MATLAB. Okay, by solving nonlinear equations. So we are opening. Let me reopen it. So by pushing this new script, you open M file. Okay, so now let me bring it up here. Okay, now how are we gonna do that? First, we define a function to be called. Okay, in MATLAB, when you say in the blue, when you type, it becomes blue automatically. You see here. Okay, so when you do this, MATLAB gonna call this function. Okay, this is coding in MATLAB. So function, now f is equal to, I have to select a name, say find root, whatever. You can say payment, you can say Brian, whatever, but it must be logical with respect to the problem. So this is find root. Okay, this is find root. Okay, of what? Of the variable x. But here we have 2x, x1 and x2. Okay, that's right. Then you see that equation 13 and equation 14. I'm defining f1 and f2. f1 as equation 13 and f2 as equation 14. Okay, exactly in the MATLAB. Okay, so you're gonna be x1 cosine x1 x2 square plus e to the power of use exponential I taught you in the YouTube links that you have, minus x2 square minus 2, and I'm moving to the other part. Okay, so we're gonna be, I'm gonna define that. So f, see here, let me make it a little small. Okay guys, now so see here, so f1, because we have two f's, is equal to x1, okay, multiplied by cosine x1, that's right, multiplied by x2 square, that's right, plus exponential of minus x2, as you see here, I'm typing here, power of 2, that's right, and minus 2. Here we go. That's right. Now f2. Look at here, guys. This is f2, this line. So x2 power of root square after x2 sine x1 cosine x2 plus tangent x2 minus 0.6. Okay. So what you're gonna get? We're gonna type it here. F2 is equal to x2 0.5 multiplied by sine x1, that's right, multiplied by cosine x2 plus tangent of, sorry for the noise, guys, this is the pandemic that we owe to transparent countries, minus 0.6. okay, we got it. I cannot do that. I cannot suppress the noise. Okay, so child, they're playing. If you hear that, that's for that. So now, then using the initial guess, we utilize the following code to solve the equations. Here we have, so because you have two variables, x1 and f2, I'm selecting the initial guess. This is guess that can be made by you. Okay, so I'm saying that my initial guess is 0 and 0. Okay. So what we're gonna do is use the code for that. So now I have to save it. I'm pushing the control and then S. So I'm saving at the ME202, that's right. And the name of this name, guys, this name must be exactly this name. Find root. They must be exactly the same, okay? So find root in ME202, that's right. So I'm saving there, okay. Now if you go to ME202, okay, you see that this is the M file. This is how we write code in MATLAB, guys. This is M file, okay. Now I'm opening another M file here by clicking on this. Look at here, guys. By clicking on this, I'm opening a new M file, okay. So this is the command that we have to do. I'm gonna say fun is equal to at. At in MATLAB means go and call that function. Which function? Find root. Find root. Okay. So go and call find root. Okay. Now I'm putting the initial guess means x0. I'm saying it is 0 and 0. Understand? This is what? This is, you can comment your code. How? This. So this you see it is green. Commenting in the MATLAB code is with the color of the green. So this is your initial guess. Understand? Now x, that is the vector of x1 and x2, this x, okay, is equal to f solve. This is the command. F solve of fun. That's right. Which fun? This fun. We define this fun. Go ahead and calls that equation. That's right. For x0. Understand? So now I have to save this. So I'm gonna say solver number 1, but must be in the same folder, guys. In the same folder of find root, or the M file that containing your equation must be at the same folder. Okay. So now if I press F5 in your keyboard or this run button here and change folder, yes, it tried to solve. So you see that it solved the problem. So your x1 is this value, x2 is this value, by having the initial guess of around the 0 and 0. See that this nonlinear equation has this solution. This is your x1, guys, and this is your x2 for such a complex equation. Okay. So now the point is, what happens if I change my initial guesses? Okay, my initial guesses. First of all, after you make change, guys, you have to push the Control S to save your command. Okay, if you don't do that, it's gonna be ridiculous. So suppose that I'm changing my initial guess for the solution of this problem. It's recording. Yes. Right. So I'm again pressing F5. So you see that this time your equation is different from the previous solution, guys. Your x1 is 1.09 there, here's 0.13, 3.8. So the message is that the solution that you have depends on the initial guess that you select. So this is very interesting, because for the nonlinear control guys, when they want to find the equilibrium points, they may have several equilibrium points to judge the stability of a given system. So now it's their function to select the valid equilibrium point. Then they are linearizing the equation around the equilibrium point. These are too much for you, but you have to know that by using the fsolve command, for different initial guesses, you're going to get different solutions or equilibrium points of the system for the nonlinear control course. Understand? So if I select 10 and I don't know, -1, okay, so if I rerun it again, oh, you see, oh, the solution is complex now. But this sucks, because we cannot have, if I'm the control guy, we cannot have a solution of imaginary, we don't have imaginary number for our equilibrium point of the system. So it means that your initial guess is wrong. Okay, so if I say this is now 20, okay, and rerun it again, so you see that, oh, around the 10 and 20 you have another solution. You have 10.9 and 20.01, and you will see eventually how we deal with the several solutions that we get from the solve command. Understand? Okay. So note that at is the tool in MATLAB to call a function defined. So now let's do I do a few of these, and then you can do the rest as the homework. Solve the following equation through different initial guesses. Okay, so I'm opening another file, okay, and closing these. Okay, closing this. This is practice for you. It's function, you have to type function. Okay, so f is equal to, now I say problem prop1, because this is problem 1, guys. That's right. Prop1 of, so I have 2x. So you can have 3x, you have 4x to find. Okay, so now f1 is equal to, this is the equation, x1 cube, that's right, multiplied by tangent of x1, that's right, until this point, multiplied by sine of x2 square, that's right, minus x2 square, right? And now I'm moving this number to the left hand side, minus 1.4. This is my f1. Okay, so let me double check with you guys. Oh, this is square. X2. Okay. Now f2 is equal to x1, that's right, multiplied by cosine x1 multiplied by cosine 2x2, that's right, plus sine x2 minus 1.6. We got it. That's right. Let me double check with you. x1 cosine x1 cosine 2x2 plus sine x2, if I'm not writing 1.6. Now I have to save it with which name? Prop1. See, so it comes with in ME202 prop1. Okay. Now, yeah, I want to save time. How? Because always I have the solver here, guys. So I'm just copying. You can Control A, select all, copy to another file. That's right. Now I'm saving this because it must call which function? prob1 that you already saved. That's right. It's gonna save. Now I'm saying solver 2, prob1, solver 2, find root, solver 1. Understand? So go and call prob1. Again, I'm saying initial guess of 0 and 0. And fun is fun. So now first of all, I'm putting CLC, means clear the workspace. CLC, clear the workspace. Okay. So and now I'm gonna run this. You see that in my initial guess, the solution of this problem is this. X1 is this, X2 is this. If I change to, I don't know, 20 and 30, my initial guess can change this, right? You're gonna get 20.42, 29. So this is another solution that the problem has. So when you go to nonlinear control, it's up to you that decide that which of these equivalent points is correct for the system. Okay. Let me also do the problem number 2, and then you can please do the rest at home as a homework. Okay. So now again I'm copying, putting here a new one. Now problem number 2, guys. I close this. I save this as problem number 2 at the ME202. That's right. So now the equation is this: x2 cubed plus x1. So problem is that x2 cubed plus x1 minus 12, because I told you you have to switch there. That's right. And here you have sine, and here you have sine of 2x2, and guys, be very careful, you have to put this. That's right. And sine 2x2 plus tangent of x1 is 6.3. It is 6.3. That's right. So we got that. So x2 cubed plus x1 minus 12 sine 2x2 plus tangent x1 minus 12. We got it. Now I'm putting this, copying and pasting. I'm saving, and this is problem number 2, and I close that. So and I'm saving at solver number 3. We had here solver number 3. Here we go. Now you see that each time I'm in the workspace I'm doing here, it's like clearing the screen. But you can put this now in your code. This is the basic of the writing code in Matlab. CLC. When you put that there, it's gonna clear the workspace. Look at here. Look at here, guys. See, when I'm running this first, see, go. What happened? Where's the mistake? It says there's a mistake here. Line 4. Maybe I'm missing there. Oh yeah, I'm missing one bracket here, the side. Sorry guys, again, let's shut down the voice. Okay. So you see that if I run this, clear the workspace. So now the solution based on 20 and 30, the solution is this, right? For x1 and x2. If I change my initial guess to 0 and 0 and rerun it, the solution gonna be this. Understand? It's recording? Yes. Okay, guys. Now please go and do 3 and 4. Okay. Hold on, if I can reduce the noise. Okay. So now, after we learned how to how to solve the set of nonlinear equation in MATLAB by coding. Now let's go for the symbolic derivative. So we know derivative from the high school, right? Differentiation is a fundamental mathematical operation in mechanical engineering field, or any engineering field actually. So we have simple rules for differentiation, but having MATLAB helps us to do it much easier. We use diff, that because of differentiation, command to symbolically diff, to symbolically calculate even complex terms differentiation. See the following code, okay? So what we're gonna do, so now you know how to, I'm gonna close this, I'm gonna close this, okay? And now I'm gonna open a new M file. How are we gonna do? So first of all, I'm saving this as diff underline 1, okay, as M file, okay, to have it per. So guys, coding in the workspace sucks because it's not permanent coding, but always you have to do your coding in the M file. So I told you that the seams gives you a symbolic parameters in MATLAB, that's right? So you have seams, here we go. Seams A, B, C, and X. Now A, B, C, D, and X, they are symbolic parameters. Now if I say diff, okay, A x square plus B in X plus C, okay, understand? Now if I push the buttons after saving, and if I first of all I have to clear the I have to clear the workspace, okay, clearing the workspace. If I push the button, now see that it's BZ. So answer is 2ax plus b, 2ax plus b. And we know this from the trivial algebra, that's right? That's right. For those of you that you forgot about algebra, it's very trivial. So come on. Okay. So d over dx of ax squared plus bx plus c in algebra is 2ax plus b. That's right. So MATLAB does it for you. Okay. 2x plus b. Now you can assign this to a parameter. Say, do this for me. Okay. So it's gonna give you your a parameter gonna be differentiation of this term. Understand? So this is very powerful tool in MATLAB. Okay. Now let us do symbolically calculate the derivative of the following terms. Okay, let's do that together. Okay, so now I'm saying, so this is symbolic, that's right, but here we have numeric. So I say b is equal to, see everything is permanent here. In the code, everything is permanent. Is differentiation of x cube, okay, plus sine of x plus sine of x in cosine 2x. That's right. Everything is right. Yeah. If I run this, oh, it gives you what? It gives you the differentiation of that term. The term number 1. Differentiation of this is gonna be this. Very quickly and rapidly. Understand? So let me, I have to arrange, hold on guys, to save time. Okay, so we see that that's there. So now you can make it a little beautiful, that's right, and pretty. You say b1 is pretty of b. Let me see if it works. I'm not sure even. Okay. No, the pretty for the symbolic, it doesn't work. Okay. So forget about that. So now part 2. Okay, part 2 is C. I'm saying is differentiation of 0.01 multiplied by x to the power 5 plus 0.2 multiplied by x cubed, that's right, plus tangent of x multiplied by sine of x squared. Here we go. Right, but now I don't want to see the result of this. I only want to see the result. So you have to put this semicolon in front of it. Now only see there is no semicolon. Only see the differentiation of this term. Now if I do that, here we go. We got to see this huge term. Understand? So, and that's another point. Okay. So now please do. Is it recording? Yeah. So please do 3 and 4 at home. Okay. So note that in 3 we showed the ln as logarithms, right, in Matlab, while ln 10 is shown as log 10. So this is Neperian algorithms, right, in the base of e exponential, but in the base of 10 we are showing with log 10, like this guy here. Guys, look at here. If I say log of 10 of 10, it's gonna be 1, as we know. That's right, in mathematics we know that logarithm of 10 in the base of 10 gonna be 1, or log of 100 in the base of 10 gonna be how much? Tell me. Yes, 2. So look at here. Or we say log of 100 base of 10 gonna be 2. But if I say log of 10, this gonna give you another number, because the base of this command is exponential ln, Neperian logarithm. Okay, exponential base command. So see that if I say log of exponential of 1, the result is 1, because this exponential of 1, that's right, means e. Remember I taught you in the YouTube links in the previous classes. So I'm saying the ln of e in the base of e gonna be 1. So be careful about this when you're coding. So whenever that you are saying logarithm in MATLAB, log means that you are in the Neperian or the exponential base. Okay? But if you want to make it to 10, you have to do 10 and your terms, like 1000. You got it? That is 3. So, and now we reach to metrics, Jacobian. That is very important, guys, in the dynamics, robotics, control, and mathematics. After learning that how we have the differentiation of the single terms, now the question is that if we have the metrics of the terms, how we differentiate that. This is a very important topic, guys. Okay, and after that you are ready for the midterm, hopefully, guys. Yes. Okay, thank you. Here we go.